Here in example 2, we're given this implicit differential equation, but now we also have an initial value. Remember, we use initial values to solve for our constant. When we're solving using separation of variables, you need to solve for your constant before you isolate y. So let's go ahead and separate variables. We have these terms of y, and this is a term of x. So in order to get all terms with y on the left, I have dy over secant y equals 1/2 times dx. Now, in order to solve these differential equations, we take the antiderivative. Remember that 1 over secant y is just cosine y, dy, plus, or not plus, equals the integral of 1/2 dx. So this is sine y plus c1 equals 1/2 x plus c2. Isolating our constants to one side, sine y equals 1/2 x plus c3. So now remember, we need to solve for y, or solve for c3 before we solve for y. So now I'm going to use this initial condition. I know that x is 1, and that makes y pi over 2. So we have sine of pi over 2 equals 1/2 times 1 plus c3. Or 1 equals 1/2 plus c3. So that makes c3 equal to 1/2. So now we can go back to this differential equation solved with this c3 plugged in. Sine y equals 1/2 x plus 1/2. So to isolate y is sine inverse of 1/2 x plus 1/2.